Hey guys, today we're going to have a little look at going over all of the things that we've learned so far on fractions. We're going to start by looking at equivalent fractions and just the different visual representations that we can use, just the fraction walls and rectangles. A fractions wall is a wall that's built up of strips of equal length. Each strip has been divided into equal parts. In other words, each strip has been divided into fractions. Using a ruler, we can line up different fraction amounts to see whether they are equivalent or not. Let's look at an example. Can you identify what fractions are equivalent to 2/3? 4/6 are. Look further down the fraction wall. Can you find another equivalent fraction? 8/12. 2/3 is equivalent to 8/12. They line up using our fraction wall. Another way to investigate equivalent fractions is to use rectangles split up into fraction quantities. You can see the top rectangle has been broken into two parts. The middle rectangle has been broken into four parts. It's showing quarters. And finally, the third rectangle, although it's the same length, it has been divided into eighths. We can see easily 1/2 is equivalent to 2/4, and that is equivalent to 4 parts of 8. What fraction is shown in the top figure? 1/4, 1 part of 4. Now look at the lower figure. Can you work out what fraction is equivalent to 1/4 using the second figure? First, I had to work out what the denominator was. I had to count how many parts were in that lower figure. 12 parts. By lining up the two figures, I can see that 1 part of 4 is equivalent to 3 parts of 12. This brings us on to the next part of our video, where we're going to look at making links between the numerators and the denominators. We have just looked at 1/4, 1 part of 4 being equal to 3 parts of 12. Well, let's think about how these numerators and denominators are linked. 1 multiplied by 3 will give us an answer of 3. 4 multiplied by 3 gives us an answer of 12. We can see that, that the numerator is 3 times bigger than 1, and the denominator is 3 times bigger than 4. The golden rule of finding equivalent fractions, it's whatever operation is carried out to the top, to the numerator, must also be carried out to the denominator. Let's see if we can find equivalent fractions to 1/6 using the two operations, either multiply or divide. Whatever operation I carry out to the numerator, I must carry out to the denominator. Well, let's look at multiplication. 1 multiplied by 4 equals, it's equal to 4. Now I need to multiply the denominator by 4. 6 multiplied by 4 equals 24. 1/6 and 4/24 are equivalent. Can we think of another? What if we multiply the numerator by 2? 1 times 2 is 2. Now we've got to multiply this denominator 6 by 2. 6 times 2 is 12. we find out that 1/6 is equal to 2/12. There is a link between the numerator and the denominator. What about 5/15? 5 parts of 15. Is there any operation that we can carry out to both of these numbers? We could, of course, multiply them. We could multiply 5 by 2, which would give us 10. And we can multiply 15 by 2, which will also give us 30. So we can say that 5/15 is equal to 10 parts of 30. But so far we've been looking at multiplying. I really would like to have a look at finding an equivalent of fraction, but using division this time. Is there a number that we could divide both the numerator and the denominator by? 5. 5 can be divided by 5. 5 divided by 5, of course, is 1. Remember, whatever operation we carry out to the numerator, we must also do to the denominator. 15 divided by 5, well, we know that that gives us 3. So 5/15 equals to 1/3. Okay, let's recap. We've been identifying equivalent fractions by making links between numerators and denominators using the operations either multiply or divide. Well, let's see if we can circle the fractions which are equivalent to 1/4. Remember that golden rule. Whatever operation is carried out to the numerator must also be carried out to the denominator. Let's test to see if this is right. 1/4 is equivalent to 4/16. Well, is it? Let's look at the link between 1 and 4. 1 has been multiplied by 4. Has 4 been multiplied by 4? 4 times 4 is equal to 16. So yes, we know that 1/4 is equivalent to 4/16. Let's continue. Is 1/4 equivalent to 2/5? Well, we're going to look and see the link between the numerator and the denominator. 1 to become 2 would be multiplied by 2. 1 times 2 is 2. Whatever operation is done to the numerator must be carried out to the denominator. 4 times 2 is, it's not equal to 5. It would be equal to 8. So this is not right. 1/4 is not equivalent to 2/5. Okay, let's speed it up a little bit and test 1/4 against the other fractions. We've identified the equivalent fractions. Okay, remember, we're finding equivalent fractions by making links between the numerators and the denominators. Now, here's your task. What is the link between 18 and 3? How are they connected? Find the equivalent fraction of 24/18. How many thirds? And another one. Let's give it a go. You can see how it's really important to know your times tables so very well to make links between the numerators and the denominators of equivalent fractions. Let's move on now to look at improper fractions and mixed numbers. An improper fraction is where the numerator is bigger than the denominator. Let's look at an example. Seven parts of 3. That numerator tells us that that fraction is greater than 1 because 1 would be 3 parts of 3. How would we show 7 parts of 3? Here we go. Here we can see each whole one is split into 3 parts and we got 7 parts shaded. So that's 7 parts of 3. As a whole and part model, that is 2 wholes, you can see that here, and 1 part of 3 left. So 7/3 is a mixed number. It is a mixed number. It's 2 1/3. We've been looking at how to change an improper fraction into a mixed number. We've used bar models, visual representations to do this. Let's have a little look at how we would do that without drawing bar models. We'll use the same improper fraction, 9 parts of 4. How we do it without a bar model is we divide the numerator by the denominator. How many times does 4 go into 9? Twice. Remainder 1. That is equal to 2 wholes and 1 part of 4. So 9 over 4 is equal to 2 1/4. Let's have a try. 19 over 7. 19 over 7 is greater than 1 because the numerator is greater than 7. So let's change that into a mixed number. 19 parts, and we're going to see how many times 7 will go into 19. 7 2s are 14. We go in 2 times with the remainder of 5. That's 2 wholes and a remainder of 5 parts of 7. That's the bit we've got to be really careful of. We must remember that the denominator will still be that 7. So 19 sevenths equals 2 5 sevenths. This time we're going to look at changing mixed numbers into improper fractions. We can show it using visual representations. You ready? We know that 1 whole is 4 parts of 4. We know this from the denominator. So there we have 1 whole. 2 wholes. Here we've got the visual representation of 3 whole parts. Now let's look at the 1 part of 4 remaining. To find the improper fraction, all we have to do is count up the parts. 4, 8, 12, and 1 more is 13. 13 quarters. Let's look at how we convert a mixed number into an improper fraction without having to use a visual representation. We'll use the same mixed number, 2 and 1/5. We multiply the whole part, 2, by the number of denominators, the number of parts. So 2 multiplied by 5 is 10. That's 10 parts of 5. And then we have 1 more 5th to add on. So it's 10 parts of 5, add 1 part of 5, which is equivalent to 11 parts of 5. Let's have another look. Here's a mixed number, 4 3/4. The first thing we've got to do is multiply the whole number by the denominator. So 4 multiplied by 4 gives us a product of 16. That's 16 parts of 4 as a fraction. Now we have to focus our attention onto the fraction part of the mixed number, 3 parts of 4, 3/4. So 16 quarters plus 3/4. Let me just make that look like a plus sign more. Will give us 19 parts of 4. We can say the mixed number 4 3/4 is equivalent to the improper fraction 19 parts of 4, 19 quarters. That finishes our roundup of fractions, part 1.